What's up, skeptics? Welcome to another episode of Reason to Doubt, your source for all things skeptical. I'm Jordan, and I am joined with a very special guest, returning guest. It's been a while, Dr. Jeff Zweerink. How's it going, Jeff?
Doing well, Jordan. Looking forward to our conversation today.
We had a great time last time talking to Jeff. Jeff is a physicist, and we talked about physics. This time, hopefully, the audio quality is a little bit better. My webcam, I had this really fancy, awesome mic that I just gotten, and then used my webcam to record, so it sounded like it was through a potato. But I'm pretty sure we got all that fixed this time. So, what we are going to be talking about today is the origins of the universe. Just something light and easy. you know and you actually wrote a book on this topic that I picked up, and it was an excellent book. The book is Escaping the Beginning, Confronting Challenges to the Universe's Origin, and I thought it was awesome, so I'll put a link in the description to that book and your other work. But why don't you briefly introduce yourself to people who haven't met you or didn't watch the other episode, and what you do?
So, as you mentioned, I'm a physicist. Actually, my official title is astrophysicist, but the reality of it is I get to do physics with a telescope because I'm far more physicist than I am astronomer, if that makes any sense. But I've just been interested in how the universe works, how to study and how things work, and that's what physics is all about: figuring out why things work the way they do. So, I've been fascinated in that. Also, grown up as a Christian, just been intrigued with Christianity and who God is and who Christ is and how we relate to God. And a lot of people perceive science and Christianity at odds with one another. I've found they actually work very well together. That does have some caveat and some nuances on it. And so some of the things I've learned through life, maybe we can discuss as we go through the show today. But really, one of the claims of Christianity is the universe has a beginning. And so that's kind of my interest in writing the book, Escaping the Beginning. Does science say there's a beginning to the universe or not?
And by the end of the book, you won't necessarily know the answer, but you'll definitely have a lot more answers than you started with. But in case somebody hasn't read this excellent book, why don't we talk briefly about what we do know about the universe, the history of time, starting with the Big Bang, moving to today. The standard model is that we started with the hot dense state, like in the Big Bang theory, and expanded to today. But how do we know that? Why is it that scientists are so confident in that idea?
Well, there's a number of things that play into that, and there's kind of a number of major steps or things that happen because you think, okay, you got this hot dense state, and really what that hot dense state is, temperatures and pressures are very large. In fact, at times it's so hot and so dense that even normal matter can't exist. So protons, electrons, neutrons, those don't even exist. They're just pure energy. And somehow this incredibly hot dense state transforms as the universe is expanding. It cools. As it cools, various transitions occur. You get quarks, you get protons, electrons, neutrons. In the early moments of the universe, within the first 3 to 4 minutes, you get some of the hydrogen fusing into helium. So the universe is about 75% hydrogen, 25% helium. And then as the universe continues to cool and expand, there's a time where the universe cools off enough that protons can now join with electrons to get atoms. That's what gives off the radiation that we now detect as the cosmic microwave background radiation. Eventually, stars form, galaxies form, more stars, more galaxies, more stars, more galaxies. And now 14 billion years later, we have, go back about 4.5 billion years, our sun forms with Earth. That's not 8 planets. And 4.5 billion years later, we're here on Earth doing a podcast talking about what we know about the universe. Now, how do we know those things? Among some of the important observations we've made are as we look out at distant objects, galaxies, and other things in the universe, we find that the farther away an object is, the faster it's moving away from us. One, the idea that it was moving away from us was very startling, but the idea that the farther away it is, the faster it's moving away from us, that's the telltale signature of an expanding universe. And so we have made measurements in the local universe and inside our cluster of galaxies. There, you don't really get the expansion because gravity dominates, but not much beyond that. You can start measuring. And you see that progressively, as you get further and farther away, the light from those galaxies are redshifted more and more, which is a consequence of the universe expanding. So that's part of how we know the universe is expanding. You can actually, if you can map out that expansion rate, you can now ask the question, how long ago was it until all the stuff we can see was conglomerated into that hot, dense state. And that you get an answer there about 14 billion years. You can make measurements of the oldest stars. There are a particular class of stars, white dwarfs. We know how long they take to form, and they cool down very predictably. So you can use those to make estimates of how old the universe is. You can use galaxy clusters. And all of those ages come in right about 14 billion years. And so that's why we're pretty confident the universe is about 14 billion years old. We can make measurements of the most distant reaches of the universe that we can measure. That's out to the cosmic microwave background radiation, but even galaxies and stars out approaching that. And so that tells us, given the speed of light and the expansion rate, the same way if you tell me, hey, I'm driving from Kansas City to California, if you tell me what road you're on and how fast you're going, I can tell where you are at all times. And if I give me all the points, I can tell you when you started as well. And so we do that with the universe, and it says that the universe, the diameter of the universe of what we can see, that stuff all sits out about 96 billion light years away from us, somewhere between 92 to 96 billion light years away as a diameter, which means the universe is about, I think it's 46 billion light years in radius. And we know that stars and galaxies started forming a couple 100 million years after the universe formed. So those are some of the things we know, and those are just observations we can make, pretty much direct observations. So uh, maybe if there's something more specific, we could talk about that. But does that get at what you're asking?
Yeah, I think a few things. I think for one, it's super cool that we get to live in a period in time when we can look out in the stars and like know all of this stuff. Like
Mhm.
even if we lived just 1,000 years ago, we didn't discover that other galaxies exist until like the lifetime of people still alive today.
I know, that's remarkable, isn't it?
Yeah, yeah, it really is. Like my mind was blown away when I heard that. But yeah, it's amazing. And also hearing things like the expansion rate, which was kind of confusing to me until someone showed it to me on like a balloon where you
Mhm.
draw like the different dots, and if you focus on one dot, any dot you pick, all of the other dots will be moving away from it. And so that's why, because like some people might say, well, if everything's moving away from us, that means we're the center. Well, I mean,
No.
yeah. Yeah. Okay, so we've got all of these independent measurements that are all kind of pointing to the same direction. I
Mhm.
think, and so that's what gives us confidence in the history to now. So if we try to probe further than that, once we've got the microwave background, we go past that. What do we know in that very early region?
So beyond the cosmic microwave background radiation?
Yeah.
Well, that one's a tough one because as far as observations of what's going on in the universe, we can't. That's the most distant radiation that we're capable of seeing at this point. Now, there may be, as we progress into the future, we may be able to detect some gravitational waves from earlier than that. But the most distant thing we can actually see right now is the cosmic microwave background radiation. Or rather, just to be a little bit more specific and precise, the cosmic microwave background radiation, when it was emitted, it has been propagating through space for just under 14 billion years and is just now reaching us. Where it is now is the most distant reach we can see something that emits electromagnetic radiation towards us. So in terms of observing the universe, we can't see anymore. But what we can do is say, all right, well, we know how gravity works. General relativity tells us how gravity works. We know how electromagnetism works because we have a good theory of electromagnetism, and we know how the strong and weak nuclear forces. Let's now take our particle physics and run time backwards and say, as we get beyond that time, what happens to the temperatures and pressures and densities, those sorts of things, and say what would go on. So that's how we know that in the first 3 to 4 minutes, roughly from minute one to about minute 3 or 4, the universe was hot enough and dense enough that it had temperatures and densities similar to the interiors of stars so that hydrogen can fuse into helium. And we can do calculations and say how much should that have happened and what sort of elements should we get. And then we can go out and measure and say, all right, let's find the most primitive material that we can and ask the question, does it have the right amount of lithium and beryllium and deuterons and helium and hydrogen? And lo and behold, it does. So we do calculations based on what we think was going on, and then we say, all right, what sort of measurable consequences, and we go out and search for those things, and in general we find that they're correct. We always find that they're correct, and there are little subtleties that allow us to probe in even deeper.
Well, yeah, I mean, if you are 100% correct, you just dust your hands, we're done with science, and then,
Kind of a boring way to do science at some level. You like to be right, but you don't want to be right all the time. So
you want to be right, but not too right.
exactly.
Yeah. Okay, so that brings us all the way to the beginning, but and that's using science as we know it today.
Mhm.
But you mentioned general relativity, and for people who don't know, that's a theory of gravity. Einstein famously made it, but general relativity is a classical theory, and that means that it doesn't have take quantum mechanics into account. And
Right.
eventually, things are going to crunch to an extent where quantum mechanical effects would dominate, and so that kind of limits, if I understand correctly, kind of the limit of like our certain knowledge, because we don't have a theory of gravity that includes quantum mechanics. Is that correct?
That's right. And I wouldn't necessarily say that quantum mechanics dominate. You just need both of them because both of them are large. And
Hmm.
so that's exactly right. We know that general relativity describes the dynamics of the large scale universe, but as you get back into that more and more hotter and denser state, you're going to need general relativity, or gravity is going to be at play, and it's going to have, it's really hot and dense, so you're going to need gravity, but you've got quantum mechanical effects. And so we think that all of, you got the four fundamental forces: gravity, electromagnetism, strong nuclear force, weak nuclear force. We know experimentally, based on what we can do in our particle accelerators, that the weak nuclear force and electromagnetism, they look very different today, but as the universe gets hotter, or as it was hotter in the past, and in the past I mean within the first second, so this is a long time ago, but we can actually do measurements inside our particle accelerators, reproduce those conditions, and show that lo and behold, these forces that we thought were two separate things are actually the same thing. And so electromagnetism and the weak nuclear force actually become the electroweak force. And we think we know how to do that with the strong nuclear force. It's a little harder to make those measurements. And then we ultimately think quantum mechanics and gravity all do that as well. And so that's why, as we're getting back to that beginning, you need both quantum and gravity. And we don't have that quantum theory of gravity today. So we don't really have a final answer. We just got the history of what we've measured and say, okay, what can we infer from that history?
I mean, we just figured out the 14 billion years. Well, that's all, you know. Yeah.
That's true. I don't want, you don't want to minimize the accomplishment, but when you're asking the big question of, okay, we need what's going on at the beginning, you need to have a theory that can account for the conditions at the
Right.
beginning. And we just don't have that yet. So
Which is, I think, something that can be a misconception when people hear Big Bang cosmology, the Big Bang, they think that's like, okay, we know what happened at the beginning, but actually, that's a description of everything like just after the beginning. We
mhm.
know, like, we got that, seconds after, but those first few millis or nanoseconds, whatever scale, the beginning isn't actually included. The bang itself isn't included in that Big Bang, but
Well, and I'll even make something that's a little bit more dramatic statement than that. When you start asking the question of, is there a beginning? That's not a trivial question from a scientific standpoint to answer, because there is no stopwatch that we're saying, oh, okay, it's running back. Oh, that's t equals zero. We got a beginning. When you ask the question, what is the physical signature of beginning? That's a non-trivial question. So it's part of what makes this discussion really fun in the first place.
that's a great point, that it's not a foregone conclusion or an obvious conclusion that there would be a beginning, or if there was, what that looks like, because the physics would be fundamentally different, or at least
Mhm.
appear different. It's a very different scenario. So let's dive into that. I mean, obviously, we don't know. That doesn't stop physicists from talking about it. So, what are the ideas for that of the beginning of the universe? What is the ideas bandied about by physicists to describe what happened before what we know?
So I think it's interesting to, if I could add a little bit of background before we get into that
Sure.
question, that if you go back to the start of the 1900s, our conception of how the universe behaved was very different. And it was different in this fashion: that we knew about matter, we knew about energy, gravity talked, Newtonian gravity, stuff moved around and there were gravitational forces, kind of action at a distance. The moon, the earth pulled on the moon, but there was no immediate connection. So this gravity kind of got propagated at a distance. There was nothing that said, here's why it works that way. And space and time were these kind of absolute fundamental quantities. They were fixed the way they were, and things just moved around in space and time. But space and time were static, absolute quantities. And that's where, when Einstein introduced general relativity, it solved it radically changed the way we thought about those two things. First, general relativity gives the physical mechanism for why gravity works, because where you've got mass, it warps the fabric of space and time, so that, if you've ever seen one of those little funnels where you can roll a penny around and it rolls around, so you could imagine the sun warping the fabric of space time. And so now Earth is just rolling around inside that well. That's why it orbits the sun. So it gives a physical mechanism for gravity. But you'll notice there that space and time now are these dynamic quantities. Space and time can be folded and bent and warped. And so that, once we started applying that to the universe, if the universe is expanding, the fabric of space-time is expanding. The question was, well, if it's expanding, what happens if we run it back? Do we run into a beginning? And there were some interesting theorems developed in the 1960s and 70s. We're saying, all right, let's see if we can apply our knowledge of general relativity to the early part of the universe. And what Hawking and Penrose were able to show very generically was, if general relativity is an accurate descriptor of the universe, and if energy behaves a certain way, then as you run time backwards, you eventually run into these singularities where the laws of physics break down. And where the laws of physics break down, that looks like a beginning. And so that was the beginning, is where the laws of physics broke down. And this wasn't just like, ooh, we don't know what's going on. It's like, the way the universe behaves no longer works. It can't be. Something fundamentally different has to be there. That's the nature of the beginning there. And so that was one way we had of looking for a beginning. But it comes with this idea that space and time are dynamic. And so your balloon analogy is actually a really good picture of how the universe behaves. It's not like the universe is expanding out into something. It's just growing larger. And if you look at the distances between any two objects that are far enough apart so that gravity is not dominating, then you'll see that everything is always moving away from everything else. I don't think that exactly answered your question, but I know it gave some of the background for it. Can you?
Well, so that's the background to the kind of like the theorizing from Newtonian physics onto relativity. So, and that gives us one picture of a beginning where the laws of
Mhm.
physics break down. That's like the beginning, but there's something fundamentally different going
Okay.
on. So, in what ways have physicists tried to explore that fundamentally different? I know
Mhm.
that not all physicists can see that there was a beginning,
Mhm.
and also there's different ways of conceiving. Well, there's a beginning. What does that mean? What does it
Got
mean to have a beginning? So,
Yeah, so that's where so I wanted to start there with the Hawking-Penrose singularity theorems, because that says, okay, the laws of physics that we know, it's impossible to probe beyond because the laws of physics break down. That's the beginning. Something outside the universe must now be responsible for it. Well, so if you fast forward, that was kind of late 60s, early 70s. If you fast forward about 20 years, um, as people were probing and looking, how do we combine electromagnetism, the weak nuclear force, strong nuclear force? This is a little bit arcane, or a little bit detailed, but it's a fun detail, so I'll go into it a little bit. As they're starting to do that, one of the things they realize is that when you talk about electricity, there are single electric charges. You can talk about an electron, it's just a negative charge, or you can talk about a proton, it's just a positive charge. Actually, that's not the greatest example because a proton's a composite thing, but an electron's a fundamental particle. There are positively charged fundamental particles. You can have what are called electric monopoles. There are just the one pole. But when you deal with magnetism, you always get a north and a south pole. There is no magnetic monopole. And what's interesting is they were exploring how to get the strong nuclear force integrated with the weak and electromagnetic force. One of the consequences is you get all these magnetic monopoles. Well, we've looked for magnetic monopoles outside of one experiment that is hard to explain, but nobody actually thinks points to magnetic monopoles at this point. There's no evidence for them. And so as one fellow, Alan Guth, was exploring this, what he realized is that there was a phase transition going on. And if you had this phase transition going on, basically the space was expanding so much that all the magnetic monopoles got diluted. And he realized that if you applied that to the universe, that you could have these symmetry breaking where you got the the electromagnetic weak and strong nuclear force the same, the symmetry breaks where you get all these magnetic monopoles, but if this expansion is going on, it's going to dilute all the magnetic monopoles so we don't see them. This is where we get this is the idea behind inflation. So now the idea is, for a while it was our universe begins, inflation happens, dilutes all the magnetic monopoles, ends, and now we have the continuing on of the hot dense state, the history we've already talked about. But as people wrestled with that, what they realized is that there's no way to get in a space-time where inflation starts and then it ends and you get the nice smooth universe that we see. And so this is where Guth came along and said, wait a second, what if you've got inflation happening and it's this stuff that happens in a material that it's not in the ground state, and where it decays to the ground state, you get inflation ending and you get these kind of bubbles that grow. If our universe was inside one of those bubbles, now you've got inflation going, and now you get something that matches the universe we see. And so this is kind of the idea that we have now. So we've got inflationary Big Bang cosmology. And the interesting thing about the inflation, you remember if I was talking about the Hawking-Penrose theorems, it was general relativity is correct and energy behaves a certain way. The energy that drives inflation doesn't behave that certain way. So that Hawking-Penrose singularity does not apply to an inflationary cosmology.
Okay.
And so now this opened the idea, once inflation starts, it seems to go on forever. Maybe it's been going on forever and there's no beginning. So that kind of changed the picture there for a number of years.
Which, in the last conversation we had, that tied into the multiverse, and I say that only because I wanted an excuse to say my favorite line from the whole book, which was one of the chapters on the multiverse. It said, I started investigating the multiverse the way any good scientist would. I typed, what is the multiverse, into Google.
You like that? All right,
Yeah,
I'm glad.
great. But if you want to hear more about the multiverse, we did a whole episode on that. Again, link will be in the description. But okay, so inflation has been going on. Maybe it's been going on forever in the past, and that would solve it. No beginning. We're done, right?
Well, it depends on what answer you want. No, you're right. So it makes a complication to this question. And so it really is the case. And there's this bizarre phenomena that happens with inflation, that though everything is growing, what you can show is that the amount of of space where inflation is happening, even though it's decaying and making other universes, that amount of stuff that's growing is always the same or growing. So once inflation starts, it appears to go on forever. And so that raised the question, might it have already been going on forever? And so this is where Alan Guth, who developed inflation, Arvin Borde, Alex Vilenkin, all of these people working in this, they were able to go along and look and say, well, okay, the Hawking-Penrose singularity theorems don't apply because energy doesn't behave that way. So they eventually stumbled upon another way of developing a singularity theorem, which just said, all right, let's look at what happens if a spacecraft is just drifting through space. And what they found is that as it's drifting through space, as it passes by, it's going along at a constant velocity. But as it's going by, observers later and later in time, because of the expansion, will see a slower and slower velocity. Okay, fine and dandy. Now run that backwards. As you go back further and further in time, eventually you run into a place where those observers are going to see this object moving at the speed of light, and there's no way to go beyond that. So no matter how I look, I'm going to look back and see a boundary that I can't see beyond. And so again, you've kind of got a beginning to what we could ever possibly know. And the only real condition on this singularity theorem were two. One, that the universe behaves classically. So we no longer require general relativity to be true, but we do expect it to behave classically. And on average, the universe or the space-time expands. And so this was, I think, published in 2003, and it's the BVG theorem. It's fairly well known, but it really it kind of updates the Hawking-Penrose singularity theorems to something more akin to what the current science of what we think is going on. It says, yeah, even in an inflationary cosmology, it looks like you still have a beginning.
So everyone, I think absolutely everybody agrees that our like local region of space-time has a definitive beginning. And what the
Correct.
BGV tells us is under the assumption that things work classically, the cosmos, whatever that entails, also has a finite beginning. Whether it's the same as our local space-time's beginning or something else, at some point there is a concrete stopping point. Is that correct?
That's my understanding of what it says. So yes, the way I would describe, so we may have our local universe, there may be other local universes. There's beginnings to all of those, but in some sense those beginnings are a lot like Sunday. It's the beginning of the week, but there's lots of beginnings. It's not a fundamental beginning. But
Gotcha.
if I understand the BGV theorem, it says there's a fundamental beginning to inflation as well.
Gotcha, gotcha. Okay, well, the BGV theorem, though doesn't have very many restrictions, it does have some, and that means that you
Mhm.
could always avoid them by just like rejecting that hypothesis. Uh,
Exactly right.
so you've got one it with that hypothesis, finite past. Are there other ideas that don't involve a finite past?
Well, one of the conditions on the BGV theorem is that on average space-time expands. So some people have said, okay, so what sort of are there mechanisms we could look at where on average the space-time is not expanding? Couple of ideas for that. And what's interesting is if you ask Alex Vilenkin, is there a beginning? And he was at I think it was Stephen Hawking's, I think it was 70th birthday party. He gave a talk on this, and he says this shows, yeah, there's a beginning to things. This is kind of almost nail in the coffin type evidence that there's a beginning. So here you got Vilenkin saying there's a beginning. And then you can ask Guth, said, does that point to a beginning to our region? Yes, it does. Does that mean there's an absolute beginning? He goes, no, I don't think so. So, here you've got two people who are experts in this idea who develop it, who asked about the fundamental implications, and they differ in what it has to say. So that's part of the fun that you get to do when you do science.
Okay, so I know there's going to be tons of different models, but could you maybe pick like what's a model that posits that the universe is eternal in the past. And how does that work? What does that look like? Probably some of our listeners are familiar with the Carroll-Chen model, just because Sean Carroll's very charismatic and a big communicator. But you don't have to pick that one. Pick anyone you like.
Well, that is one that I think, or that I would pick out, is that there's this idea that, okay, so we're seeing space time expand and we're moving off this way, but it could be that as you move, space time expands in two different directions. And so we're expanding here, we're expanding there, but on average, there's no expansion. And so that would not be subject to the BGV theorem. There's also, I think, one developed by, I'm almost positive it's Roger Penrose, but I'm just I've got the person's image or the face in my mind, and I may be wrong on the name there, but it's called this conformal cyclical cosmology. And here the idea is that yes, you have a big bang, the universe expands, but eventually it dilutes itself to the place where there's no matter, and that when that happens, every region of space replicates what it looked like at a big bang, and so the process starts over. And so it looks like on average everything expands, but the reality of it is it's kind of a cyclical cosmology. So you expand and then so it again is no longer subject to the BGV theorem. Another way of doing it is you could imagine, okay, so we're tracing time backwards in our universe, and yes, it expands, or it's contracting, because as you go in the future, it expands. As you go in the reverse, it contracts. You go through, get outside our bubble, you've got inflation, and now it eventually contracts down to a minimum size state. And on the other side, it kind of would bounce through that. So it could in principle be contracting for eternity, bouncing and expanding for eternity, but on average, it is not expanding. So these are some of the ideas that are out there. Many of them involve quantum gravity models of some sort, because those seem to go hand in hand in the discussion. But these are some of the ideas for universes, if you will, that would not have a beginning, that they would be future and past eternal, if you will.
Yeah, the bouncing one, I think I can kind of grok that. Sean Carroll's okay. There's like an inflection point. The one where I forget the title you gave it, but where everything dilutes away into like basically that everything is back to the beginning because all the matter's gone, and if all the matter's gone, there's nothing to say where time is, so time just starts again or something. Like that's almost how it was described to me. Probably a very
That's
poor
what
description.
it's yeah, no,
Yeah,
that's pretty much
and
it. So
like I don't know. I'm not a physicist, so I can't say it's wrong. But man, that is hard to like wrap my mind around. Um,
it really is, and honestly, that's one of the things. It's a little bit of a diversion from our conversation, but I was just reading an article the other day talking about what is the geometry of the universe, and what I mean by that is, if you take a two-dimensional surface, you can have different kinds of geometries. You can have it be a flat piece of paper, that would be Euclidean space. So that's where one of the characteristics of telling whether in a Euclidean space is ask what happens to parallel lines. If they stay parallel as you move through time, you're in a flat geometry. Now, you could also have where that space wraps around back on itself like a ball. And it would still be two-dimensional, but it would be a ball. And you could have a two-dimensional where it spreads out like a saddle. So in the ball, parallel lines converge, in a saddle, parallel lines diverge. Now, that's pretty straightforward, but now you could ask the question, is our geometry that simple? Might it be that it's more like a donut rather than a ball? Or, you could have three-dimensional donuts. And all of those things, we can't rule out those possibilities. So this is one of the challenges you have in science is there's almost always a more complicated explanation to observe or to explain the observations. The question is, how do you decide which of those is correct? And ultimately, the history of science, what's worked so well is that we said, here are some observations we could make that say this one's more likely than this one, so we're going to go with the simplest one that explains everything. But these are some of the challenges you encounter as you're starting to probe into these really fundamental questions.
so I want to get to the theological implications of some of these questions, but since you mentioned that falsification, the confirmed predictions, what are the sort of predictions we might possibly one day be able to make that could help us to differentiate between these different ideas?
So that's going to be a challenge until we develop a good quantum theory of gravity. So I'll just go back to, we talked about the singularity that arose because of the densities that happen in just generic Big Bang cosmology. Well, here we've got a model for how the universe behaves. We've got a mathematical description that we can now push the description into what would be a beginning or an end and ask the question, is there one, and why and then ask the question, okay, if this model is correct, one, do the observations support that the model is correct? And does that model still apply where we're getting these extreme conditions? So that's why the Hawking-Penrose theorem, it's still a valid theorem. It just no longer applies to our universe because we know if inflation happened, that violates one of the conditions for the theorem holding. And so these are the sorts of questions you'd have to say is, all right, let's develop a quantum theory of gravity. And then now let's start to probe, does it have a beginning or does it not? Some quantum gravity models that we have today have this maximum compressibility. So instead of getting a beginning, you kind of bounce. It's kind of like a sponge. You can squeeze it, squeeze it, squeeze it. Eventually it just recoils. And so, but the challenge with all those quantum theories of gravity is that we have no data that distinguishes and says this one right, this one's wrong. Thus far, all of them pretty much line up with all the data because we don't have the data that would actually be able to discriminate between them.
Well, you're a physicist. Get on it, Jeff. Give us.
I've been working, actually, I will read about people who work on this because this is pretty high level math, and it deals with math that happened beyond the place where I actually understood the math. I could still do the math, but I didn't just understand it. And so there are people out there working on that. But this is, I mean, we've had challenges like this. You go back to the 60s and 70s, looked like, well, okay, we just got this boundary that we can't peer beyond. There's laws of physics break down, we're just stuck there. Well, as we continue to develop, actually studying something in particle physics was what opened the idea that maybe inflation happened. And now that gives us tools to explore what might have happened before that, the beginning of our universe, if you will. And so I don't know what those are going to be. We just kind of have to wait. But the challenge you and I have here is that we kind of would like an answer to this question, but we don't have the data that actually, or they don't have the data and the information that gives us a definitive answer. So we build a case and say, hey, here's an argument I would make why there's a beginning, or here's an argument I make why there isn't a beginning. And so I would like it to be different, but it's not going to be different probably for 15, 20 or more years.
Well, hopefully we'll be both be around when they figure it out. That'd be really neat. Uh, okay, so we've talked. So we have a good picture of what the state of the science is to date, but obviously we're not going to have an answer today. But we can still ask, like, if the universe is this way, what is that? What are the implications of that?
Mhm.
And the other way. So uh, in some of the later chapters of your book, you talk about the theological implications of the universe having a beginning versus not. And it's your contention that Christianity predicts that there would be a beginning to the cosmos. There'd be a finite beginning caused by God. Would you say that that would be like basically the? Are you saying that if the universe doesn't have, sorry, when I say universe here, it could be very confusing because the universe doesn't mean this universe or the whole thing. I'll
Right.
try to say cosmos if I mean the whole thing, but okay. If the cosmos doesn't have a finite beginning, if it ends up being bouncing, does that mean that Christianity is false, or would you have to like change your theology? How would that work in your mind?
That's a great question. And that's kind of what I've been wrestling with because there are some people I've interacted with, who've made an argument that their argument was along the lines of, well, hey, if time is a created quantity, so whether it has a beginning or not, it's still created. And so that's one of the you can't get away from ideas out of scripture is that the universe or the creation is created ex nihilo out of nothing, that everything in the universe is dependent upon or contingent upon something outside of the universe. And so, in that way of looking at it, time could still be created and not have a beginning, but still be contingent. And so, there are some people who've wrestled with it that way. But as I've talked to various theologians and just kind of asked the question, I we haven't talked about it here, but this is the same question I was wrestling with in looking at might there be extraterrestrial life out there? And so, kind of asked the question, well, if we found life, would that be a problem for Christianity? And as I investigated, I realized you can make reasonable arguments of whether God created life here on earth or God might have created life out there as well. And so that wasn't a discriminator on whether Christianity was true or not. As I've talked to various people about the beginning seems much closer to a this is the way the Bible describes the universe. If there's not a beginning, that means the Bible's not properly describing the universe. And I think that would falsify Christianity or come much closer to that. Now, that being said, there are some caveats on that because as you mentioned, there's the our local universe and there's the cosmos. I think you probably could make an argument that even if the cosmos may be eternal, created but eternal, that the fact that there's a beginning to our local universe aligns with what's being described there in Genesis 1. In the beginning, God created. There's still a beginning, but it's a little more phenomenological rather than fundamental. So, I would love to say, here's the definitive answer, but most things in like a lot of things in theology and a lot of things in science, there's subtleties to every position you're going to articulate.
That was actually the thought that occurred to me as I was reading that. Um, that I was thinking like putting on my Christian hat on, and I was thinking, okay, what's the purpose of the scripture? It's to, instruct us, to help reveal the divine to us, to help us build a relationship. And so it's telling us things about this God and the things that happened, right? But if the purpose of that book is to communicate to humans, then I could imagine an argument where if the cosmos was eternal, but our universe was created, even if that might appear to conflict with in the beginning God created, one could argue, well, in the beginning God created everything that concerns you, but that doesn't
Mhm.
mean
Yeah,
that he didn't tell you about the life that he made in Alpha Centauri because it wasn't
correct.
a concern to you, and same thing.
Mhm.
So I think that while it would lead to some wrestling, some difficult questions for some people, I don't think it would end up being like a death knell it would change people's conception, but I don't think it would be a serious like roadblock. Uh,
I would tend to agree with that, and I'd take a little bit different path to get there. More is just like there are places where the Bible describes stuff like sunrise and sunset, where it's giving a phenomenological description. The phenomena, if the phenomena looks true, then it's correct, even though we know the sun doesn't rise and it doesn't set. The earth actually spins on its axis. So, but the Bible's never purporting to give a here's the actual details. It's saying, yeah, the sun rises and the sun sets. So the fact that it might be using phenomenological language wouldn't bother me so much.
mhm.
Now, that's predicated on the idea that when you theologically and do the exegesis of what in the beginning means and where it talks about in the beginning and John, in John 1, in the beginning was the word was with God, if the theological exegesis of that says, no, this is a creation ex nihilo, there's nothing, that it is the fundamental beginning, then that's a different question. And I actually tend to lean closer to that way of looking at it, more kind of keeping in mind that maybe that's wrong and it might be more phenomenological. But I would actually make, in my arguments, I would make, yeah, it's a fundamental beginning that's being described there.
So if so it seems like when you say that this is a prediction of Christianity, it's almost like kind of like the BGV where like here's and that's not us making predictions of the theorem, but it's kind of like saying if these things are true, then this. And so if your understanding of creation ex nihilo is true, then that version, that conception of Christianity makes the prediction of a firm beginning. But
Right.
if that's wrong, if we found out, in 20 years that there is no firm beginning, that the universe is in some sense eternal, then do you, in your mind, in Jeff's mind, do you
Mhm.
think it would be likely that? I would imagine the conclusion would be, well, I was just wrong about the exegesis. Then, you know.
That's the question I would have to ask. And there's a common discussion or tension when we're talking about scientific issues inside the church. I'm going to say this just to be articulate and clear in the way I think about it, is that there's kind of a perception that a lot of Christians who are engaged in science, well, they go, well, this is what the science says. Let's go interpret the Bible this way. So if the way I would have to look at that is that I don't get to say, well, the science says this, so I need to interpret the Bible this way, or well, the Bible says this, so this is what I'm going to find or this is I need to interpret all the data this way. As a scientist, there's a set of tools I have for investigating the universe, and I need to apply those tools well and recognize there are limitations and strengths. Like with the Hawking-Penrose theorem, it's like if this and this, then this is the conclusion. So I can't overstate my conclusions, but I shouldn't understate my conclusions. The data recognize there may be other models that fit this, and so if I'm honest and have integrity, I recognize all that. Well, that has no necessarily theological input to it. Similarly, when I go look at scripture, I have to go do the same sort of process. Theologians that say, here's how you interpret scripture. There's historical grammatical method, and there's these kinds of genres, and you have to do this and that, and you have to look at what Genesis and Matthew. I've got to go then ask the question, okay, if it really says there is no fundamental beginning, theologically, using good exegesis, can I get there or not? And if I can't, then I really do have to say they're at odds with one another. And if I can, then I say, okay, I've still got a way, or there's still my expectation that what we find in script creation and what we find in scripture are going to line up when we understand them, and I find they do. So I'm that model is still in play, and so it's not like I just get to say, well, because of this, therefore I've got to look at scripture differently. I still have to do things well. It may just mean that it's wrong,
Mhm.
or it may mean that the science is wrong. But generally, I've found that just means I need to go study more because I don't understand everything I need to understand.
So it seems like then you'd be in a situation where a firm beginning to the cosmos and the way way it's understood now would be it would be evidence for, and if that's evidence for, then evidence is symmetrical, so not seeing that would be evidence against, but it wouldn't be telling in either direction necessarily. Would that be fair? Like if we found and I want to dig into the okay, what if there is a beginning thing here in a second. But
Mhm.
if you could get there, if there's a path to get there with proper exegesis to say that you thought the Bible was telling you this thing, turns out you were wrong.
Mhm.
There's a path to get to align the two. Then it wouldn't be the case that you'd have to necessarily abandon your faith. Is that fair to say?
I would tend to lean that way. Again, it's a little. I always have trouble playing the what if scenarios because you can play what if scenarios
Well,
without all the emotional baggage.
yeah,
Whereas, in the moment of it, I really have to evaluate: can I, in good conscience, given this data, can I say that they still align with each other? And I have trouble doing that outside of the actual
that's fair.
circumstance.
That's completely fair. I mean,
I think I would go along and say that if we find there's no actual true beginning, as a friend of mine says, I would still be a deist because I think there's a lot of evidence for a divine, but I would no longer be a Christian because that would show that Christianity doesn't describe the universe the way we see it.
that's fair. Well, okay, so let's go the other way. Let's say we in 20 years we figured out and whew, we got a beginning. We're good. So now the pressure is on me. Would you first of all let me I don't think you mentioned the book, so maybe you didn't. I don't it I had a terrible flu in the interim which knocked away some of my memories. But would you say that if there is a beginning, that means therefore Christianity is true, or would you say more like this is a confirmed prediction that's evidence for Christianity, but you could still make arguments outside of that?
I think it lends, well, I think what it would do is that it would falsify any sort of eternal sort of
Mhm.
ideas. That if there's a beginning, you no longer have an eternal creation
Right.
or an eternal physical. So that's the biggest distinction it would make. Now, I don't think Christianity is the only way of looking at that says there's a beginning to things. Um, Honestly, I think I've heard naturalists argue that we might be able to get a beginning, and so there again. All of that is in the details. How does it play
Right.
out? Because that's I mentioned at least in one of the chapters in the book. Krauss's idea of a universe from nothing, where he's arguing a universe that has a beginning, but you don't need God.
Hmm.
And I don't think he articulates the case as well as it could be made there. And I do always feel necessary to make a caveat that Krauss is really taking Vilenkin's idea of how to do things. It's not his development, but he's saying, okay, if Vilenkin's idea is correct, we can get a universe without need for a God, or at least a personal God. Because
Hmm.
even in his book, if I remember correctly, he says it doesn't, a universe from nothing. His idea doesn't rule out God; it just rules out a personal deity. I don't even think it does that. But if he's correct, even you see how even in these, it's not a clean either or.
Right.
There's always a little bit of uncertainty in what the actual implications are.
I think that, like I said before, evidence is symmetrical. So if you see if
Mhm,
something if not seeing it as evidence against and seeing it has to be evidence
mhm,
for, right? And I think something that my fellow atheists often seem to, or at least a kind of a trick of a language that they don't, I think, articulate the best all the time, or maybe don't think about it the best all the time, is having evidence for a thing doesn't mean the thing's right. Like wrong ideas have evidence for them, right? So
mhm,
that's just the reality, right? And so I think I would concede that if the universe, if our cosmos had a finite beginning, I'd have to say that's evidence for the conception of Christianity you're talking about, because that's like what you'd expect to see if it's true, right? So that's
mhm.
evidence for it. That's just what it means.
Right.
Um, but at the same time, I think what it would definitely be evidence for is some kind of brute fact beginning, because eventually you can't go any further past. So you have to say, and
Mhm,
then the reasoning kind of stops, right?
right.
So I think at that point we'd then be in a position where we just have to debate. Okay, we have a beginning, we have
Mhm,
a proof. There's some kind of cause. What is the nature of that cause? And
mhm,
that's where we could get into like the things like the kalam and all that sort of stuff, which we don't need to unpack all of that here. But like, why would you be inclined to say, okay, let me I was about to, I think what I was about to say is confusing. Let me try to rephrase it preemptively. So
mhm,
uh I could say, okay, the brute fact beginning is that we need something, maybe it's energy, maybe it's some kind of fundamental
mhm,
laws of physics. That's the thing. Why not that as opposed to a personal deity? Because we at least know that things like energy or matter, or whatever the thing, what some kind of physical thing, that's
mhm.
the kind of thing we know exists, right? And so, why would you be inclined to invoke a personal deity instead of like kind of holding up that thing we already know exists?
No, that's a good question, and I explore that in one of the chapters in the books. And to me, it seems like you kind of have three options for what the brute reality is. Okay, so you've got a beginning. or the fact that things have a beginning, you end up in one of three buckets. And I think this is exhaustive, but I just haven't studied it carefully enough to say that definitively, but I'm pretty sure. So you end up either in a what we think is the beginning is not really the beginning, and you end up with some sort of eternal physical stuff that matter is eternal. Uh, that's one option. Or and this is really what Krauss and Hawking are exploring in their ideas, is that yeah, there's a beginning to the physical stuff, but there are these laws that drive it, if you will. So the laws of physics, the laws of gravity, whatever, Hawking and Krauss use two different terms for it, but ultimately there's this model or this mathematics that drives everything. So the mathematics is the brute reality that exists that drives everything else. So you got the matter that drives everything, you got the mathematics that drives everything, or you've got a mind that drives everything. And I think, to me, why I find the mind the most compelling, or among the reasons in that, is that from a scientific perspective, we've looked at whether the universe has a beginning. And in my book, I kind of make an argument. It's like the argument I make is scientists have repeatedly thrown and said, okay, well, maybe since Einstein proposed his general relativity, that's where it says, okay, the idea that the universe had a beginning, that's seems to be a pretty significant model. Here's how we get around it. Maybe we got a cosmological constant. Maybe there's an oscillating universe. Maybe there's a steady state universe. Maybe there's a multiverse. Maybe there's a. And it seems like scientists have come along and said, okay, here's all these ways we don't have a beginning, and the universe seems to keep pushing us back to a beginning. That Christianity articulates the beginning, and that ultimately God is the source of that beginning. That I think that's a pretty powerful piece of evidence for me why I go that way. The other piece that I think plays in very prominently is that if you're just going to say, well, let's say matter or mathematics, there's a very impersonal nature about that. Mathematics doesn't decide things, mathematics describes, and even if it's prescriptive in that it's causing and describing, it's not making choices. It's following a prescribed path, if you will. And the same is true of matter. And I just find it a little hard to get from there's this non-conscious thing that is resulting in me thinking about why am I here and what's the explanation for it. So the fact that we're having this conversation and that humanity has had these sorts of conversations, I find that a lot harder explanation to find a satisfying explanation in a matter is ultimate and mathematics is ultimate, where the mind makes perfect sense of that.
So it's kind of like a hard problem of consciousness sort of thing. Like we're conscious, we have a conscious experience, but how would you get something that is thinking and self-perceiving from a universe that isn't? Y-
Yeah, it seems like the effect, the consciousness, is greater than the cause. Now, like I said, that's not a showstopper. I know people are working on that, and there's lots of things where we haven't been able to explain now, and maybe we explain later. So I'm open to that. I think that's from a considering ideas perspective. That's a very real possibility. I do find it telling that we've spent a lot of resources trying to do that and haven't found any particularly satisfactory explanations or a lot of progress there. And so that to me weighs in as evidence that the mind is the ultimate, the brute reality behind everything.
Well, we're at almost an hour, so I won't dive into the hard problem of consciousness at this point. Maybe we can talk about that next time. But I do
Right.
want to just so the purpose of this channel. The reason that I do this all the time, and Jared does too, is because we're skeptics and we think that skepticism is a valuable tool, a way of looking at the world. And to us, all being a skeptic is believing things for which you have good evidence, requiring that good evidence to believe things, but also being willing to change your mind when you find new evidence. You were
Mhm.
wrong, cool, change my mind, boom, I'm not wrong anymore. Too easy, right? And I wanted
Can
to,
can I ask a specific question about that? Just
of
because
course,
and this I hope this doesn't come across as snarky as attacking, because it's not. So would you say that given what I've articulated, I have good evidence, good reason that I'm applying skeptical reasoning to my Christianity at this point, given what you've heard. And I realize you haven't heard everything I've had to say, but
Yeah, I'd say so. I
okay,
think,
right, that's fair.
unlike a lot of people, and this kind of irritates me a little bit, actually, I don't see religion and skepticism as contradictory things. I think that
Mhm,
you could be a Christian, like reasonable. There's space for reasonable disagreement. Two people, reasonable
mhm,
people, informed people can look at the same evidence and come to a different conclusion. They can talk about it, right? And as long
mhm,
as, like, if I look at the evidence, I'm trying to use that evidence to lead me to the truth and not the other way around. And I'm trying
mhm,
to be open to other perspectives. Like, I'm practicing that good virtuous skepticism, then I'm a skeptic. And if you look at the evidence and you with your experiences, you're doing the same thing, we can come to different conclusions and still both be good skeptics. And so the fact that I wanted to actually highlight something that, if people listen to our last conversation or this one or read your book, a common theme is, here's what I understand, here's the limits, here are things that could change my mind, here's like
mhm.
the kind of questions I'm asking. And these are all marks of a good skeptic. So I just wanted to say that you know, I think that skepticism is a wide tent. Anybody is welcome, as long as you're willing to question things, and that should be questioning things is where the fun is anyway. Um,
I could not agree with you more about that. Questioning things is a whole lot of fun. It's honestly, I have to say, a lot of why I am why I am more convinced of the truth of Christianity is that I find that it holds up under that intense questioning. But I also find that the more I ask the questions, it's like that's what drives me to a deeper understanding of stuff. It's where you just say, "Well, this is what it is, and I'm going to believe that." I think there's a place for that, and we have to do that just to live life at some level. You can't just be skeptical of everything. You got to actually say, "All right, I'm just going to take this and go," while you're still asking questions. But you do have to just kind of go with things at times.
I,
But the more you dig in, that's where I really get it's the fun where you really get a deeper understanding of things. So
Yeah, and I don't think people need to be afraid of it. I having gone through a deconversion experience, I know it can be disconcerting and it can be troubling. But at the end of the day, if you're looking at the evidence and allowing it, all that's going to happen is you're going to get closer to the truth, right? And so
mhm.
that's, if you're doing it right, and there should be nothing to fear from the truth. So that's why I'm not worried if I look like at various arguments for Christianity. I would love to be wrong, because I don't know about you, but I am terrified of dying. So if someone could convince me I don't need to do that, that would be great. uh,
Well, I love your statement there because I think increasingly your statement is at odds with the way our society is going, as being passionate about finding the truth. Now, obviously, you think you have the truth, or you think you have what your perception of the truth and my perception of the truth differ at this point. When it comes down to the fundamental, is Christianity right or wrong? We differ on that. But both of us, given your statements and my statements, we agree there is a truth and we are wanting to find what that is. And I think that is something we do not want to give up in our society easily or without a lot of fight, because I think that provides the basis for being able to differ and disagree and do it in a constructive and healthy way, as opposed to just degenerating into a power struggle. So,
yeah, I think that we can come together in our shared pursuit of the truth, and
mhm,
understanding that I only have the perspective of the life that I've lived, and that's a limited perspective. And so
mhm,
I'm very unlikely to stumble onto the ultimate truth of the reality through the path that I just happen to walk in life, right? And so I'm only going to be helped by talking to people who disagree with me. One of the things I say constantly when I talk to engage with uh, people disagree with me is, I want to know if I'm wrong, and the I am extremely unlikely to find out I'm wrong by talking to people who agree with me. So
it is hard. I would agree. If I could just share a small story, there was a conference I was at, and I was talking about the evidence for a beginning, and I made some statement to the effect of, the evidence that we have points to there being a beginning to the universe. And there was a fellow in the audience who came up to me after. He actually asked a question, and I just, we had a brief interaction during the Q&A, but he came up afterwards and he says, you say all the evidence points towards a beginning, but here I've got 3 or 4 quantum gravity models where there isn't a beginning. What do you do with that? I'm like, oh, hadn't thought about that. And that's a lot, that interacting with someone who had a difference of opinion, who articulated it well, so that I registered the weight of the argument he was making. now I can go off, think about that. It has changed the way I articulate my argument for for the truth of Christianity. It caused me to go in deeper. In fact, you'll see the flavor of it in how I wrote the book, because that book would have been very different had I written it before that interaction. So I agree with you. Interacting with people who have different ideas, it's challenging because it makes you think, but it's challenging because it makes you think.
Right. Well, thank you so much for coming on, Jeff. It's always a pleasure, lots of fun. Where can people, if people want to hear more about what you have to say or kind of follow your work, where should they go?
So the best place to go would be reasons.org. That's just our website, Reasons to Believe. It's got lots of resources. You can find the books we've written, the DVDs we've produced. Well, do we even sell DVDs anymore? That's an antiquated technology. But where you find videos, we've got a YouTube channel, Reasons to Believe. You can also follow me on social media, RTB_official for RTB as a group, RTB_J Zweerink to get to me. Facebook, a little bit on Twitter. I tend to do more on Facebook at this point, just because it's a little better to have a conversation when you don't only have 288 characters. It's hard to have a good conversation there. So.
Brevity is the soul of wit, Jeff.
Yeah, it's also the trigger for not having any substantive comments in what you say.
So all of those links will be in the description. Strongly recommend checking it out. Again, even though Jeff and I disagree on a lot, I think it's clear that we both agree that asking questions and pursuing those answers is only going to help you. And so I encourage you all to do that, to go seek out people who disagree with you and really engage with them, because you know what? Maybe they're right. And then you can just change your mind, no problem. Anyway, thanks for coming on, Jeff. Really appreciate it. Everybody, if you like this stuff, like, comment, subscribe, do all the cool YouTube stuff. But until next time, remember, you've always got reason to doubt.